end with this question posed to you, which is, as a developer community, what would you want? What should we do next? We're really looking forward to see what developers build with this technology, and we also love your feedback. We're going to take questions at the end of this talk, but now I'd like to introduce Mike from Tailspin.
Thank you. That's actually incredible work, and we're really happy to be the beneficiaries of this team's great work. So at Tailspin, we create immersive spatial computing products to transfer knowledge that reduce the time to learn and master communication skills that allow us for an increasingly collaborative workplace. We spend approximately a third of our lives at work. The other third is sleeping, and for the final third, really just personal time. And I'm guessing, like a lot of you, that line between personal time and sleep and work time isn't really balanced. So our mission really is to make the third of our work devoted to work, engaging and empowering for everyone. And it's this focus on training, really, that gives us a unique approach to hand tracking. We utilize a learn while doing approach that prepares us for real-world experiences and the daily interactions that we have in the workplace. We can recreate any environment and simulate variables to create a virtual sandbox of learning that is repeatable, and it's continuous learning. It's not a learn it and leave it philosophy. These are immersive learning environments that react to your actions and help to improve retention. VR is also uniquely suited for object-based training. To see objects from any angle and scale creates an awareness of how objects and systems relate to one another. And even more, to be able to see objects in context applied in the field. And that's a huge advantage for companies, considering it's almost impossible to be able to train people on location. It can take years to be able to accumulate that much knowledge. And as you can imagine, it's very hard to transfer that knowledge to others. Another area that we're really excited about is improving soft skills. These are conversational systems with virtual humans using AI to simulate realistic conversations. Like the other training scenarios, we're able to practice this in a safe and controlled environment. Tailspin uses VR to make learning enjoyable and prepare us for new jobs or just make us better at our current job. However, there are challenges we face, and VR has placed many in getting into the enterprise market. Considering the headsets, the controllers, the peripherals, the specialized PCs that are often expensive, not to mention the space, and if you haven't seen a corporate office space lately, it is definitely smaller than a developer's office space. And in particular, controllers. These represent a skill-based tool that needs to be learned. We've come to expect this in consumer applications in this onboarding learning curve, but these are our personal time. But at work, time is money. And workers, these are our customers, need to learn a new skill. Just to learn a new skill, that's not very intuitive. They need to be able to jump in and build real-world skills, not virtual skills. So we were already very excited when we heard about the Quest. It overcomes some major hurdles to reach our audience. No expensive PCs, no wires, no cameras to set up, and it's mobile, right? So finding space is relatively easier. So from our perspective, how could this get any better, right? Well, when we found out that there was hand tracking coming to the Quest, we jumped on the opportunity to give it a try. So the video you see was captured directly from the Quest using hand tracking. It's a training scenario designed to train insurance agents on residential water damage. Now, it was originally created for use with a controller, and we learned a lot of interesting things when we adapted it for hands. Hands made interactions almost immediate, almost intuitive. And those were huge benefits for onboarding. But that also had inflated expectations in the experience. Suddenly, people wanted to interact with everything. We fell victims to the principles of interaction design. People wanted to pull open drawers, lift cups, and all the things that you would want to do naturally. Made sense. Comparing the original demo on the left to the modified version using hand tracking on the right, the two look completely different. They feel completely different. The controller version used traditional mechanics. You scan the room with a beam, look for interactive objects, pull the trigger. The side effect to this, however, was that it limited mobility. If I can select an object from across the room, why move there? For the hand tracking version, we actually had to modify the design of objects. For instance, we also used a simple push mechanic for all the interactions. So just one mechanic for all the interactions in the demo. And within the experience, when people came up to a cabinet with a pull knob that had to be pushed to open, that became counterintuitive. So we removed the pull knobs, replaced them with push plates. Simple. There was a lot of changes like this throughout the entire environment that had an immediate impact on the experience. Hand tracking can overcome controller skill-based barriers and make our products directly applicable to training. VR has a unique opportunity to redefine natural gesture control. Unlike adding a new controller paradigm to an existing platform, interacting with virtual objects feels natural. VR, there we go. Interacting with hands and fingers is an intuitive and satisfying experience. Seeing your hands reinforces scale, usability, and physical presence. It's an instant get it. Position can always be sensed perceptually. Seeing my virtual hand mimic my motions in real space feels real. And untethered, hand tracking heightens our sense of exploration. Not to mention the emergent interactions. Motions convey emotions, intent, and purpose, opening the door to meaningful communication and character behavior. This is an entirely new paradigm that also comes with some unique challenges ahead. Obviously, there's a never-ending need for optimizations. Tracking speed and gesture accuracy will only improve consistency and quality. Hand-to-hand interactions will unlock entirely new capabilities. And multimodal support will add precision and new opportunities for training. But most of all, we hope that this is just a gateway to improving the technology in the future. That's it for me. Thank you. Please welcome Kaylin Ray from Magnopus X.